Hello, this is the next section in our geometry text. We're in section 6.4, and in this one we're going to talk about characteristics or properties of rectangles, rhombi or rhombi, rhombuses, plural of a rhombus, and squares. What are their characteristics? How do we know, how can we tell if this is a rectangle or if it's a rhombus or if it's a square? What's special about them? Remember, these are all special types of parallelograms. So everything that we've learned about parallelograms will also be true for rectangles and for a rhombus and for a square, only they're going to have some added extra characteristics as well. So that's what we're going to find out about in today's video. So the first characteristic we're going to talk about is something that is unique and special about rectangles. If a parallelogram is a rectangle, so all four angles are right angles, then the diagonals will not only bisect each other, but also be congruent. This is really important in the area of construction. If somebody is trying to frame out a window in a house or in a building, how can they tell if their frame is exactly square? You just compare the diagonals. If the diagonals are not congruent, then the corners are not square and they need to readjust it. I've seen some addition put on my house. I built a garage next door. I've seen this and how important it is, especially, you're pouring a foundation. Does the construction worker, does the contractor compare those two diagonals to make sure the foundation of that building is square? Really important to do. If we have a rhombus, and I've drawn the diagonals of a rhombus, what is awesome about the diagonals of a rhombus is they will bisect the angles. Other parallelograms don't do that, but if it's a rhombus, they do. So the diagonals of a rhombus will exactly cut the angles in half. That's how you can tell it's a rhombus. Another characteristic of a rhombus and of its diagonals is that they are perpendicular, always. So not only do the diagonals bisect the angles, but they are also perpendicular to each other. They will form right angles. Here's an example of a type of problem that you could be given. Here is a diagram of a quadrilateral, and notice all four sides are marked the same. So you know this is a rhombus. And you are asked to find the measures of all the numbered angles. So what you need to do is understand the qualities of a rhombus, its characteristics, and from that you would be able to figure out the measures of the angles. For example, if you remember that the diagonals of a rhombus are perpendicular, then you know the measure of angle 1 is 90 degrees. If you remember the characteristic of diagonals of a rhombus, that they bisect the angles, since this angle is 34, then angle 2 must also be 34 because that angle was cut exactly in half. So the measure of angle 2 is 34 degrees. Okay, I added a few more markings to my diagram because I want to find the measure of angle BAD. So that's the large angle here. Remember, this is a parallelogram. A rhombus is a type of parallelogram, so opposite angles are congruent. Since this is 34 and this is 34, angle BCD is 68, so across from that, BAD would also have to be 68 degrees. Now let's find the measure of angle 3. Angle 3 is here part of angle BAD, but because it is a rhombus, that angle was cut exactly in half, so the measure of angle 3 has to be 34 degrees, which is half of 68. Okay, let's find the measure of angle ABC, this angle up here. Remember that because this is a parallelogram, consecutive angles would be supplementary. If this angle here is 68, then this angle is 180 minus 68, or 112 degrees. And then lastly, I want to find this measure here where the number 4 is, and it is half of this 112 degrees because it is a rhombus. That diagonal cut that angle exactly in half, so half of 112 would be 56. This is 56 degrees. There's other ways to solve these as well. Notice, because these are right angles, these are right triangles. So once I found angle 2 and angle 1, I could have found angle 4 because these two would have been the same. I could have used the right triangle equals 180. There's lots of different ways to approach it, and it's so consistent that no matter which way I go, I will get the right answer because it is foundationally consistent, just like its creator. Okay, now I have a parallelogram. I'm trying to assign it a very specific name. What's the most specific category I can put this parallelogram into? So I need to look at its characteristics. Now I'm going backwards. From the characteristics, what shape is it? So let's look at the diagonals. If the diagonals are congruent to each other, right away it is a rectangle. Again, looking at the diagonals, if the diagonals are perpendicular to each other, then you know it's a rhombus. I am presupposing, though, that we already know it's a parallelogram, not just some quadrilateral. We know it's a parallelogram. It's what type of parallelogram is it? That's when we check its diagonals. If they are equal to each other, it's a rectangle. If they are perpendicular to each other, then it's a rhombus. Another thing you can look at is if the diagonals bisect a pair of opposite angles, not just one angle, because that could be a kite. But if they bisect a pair of opposite angles, then it is a rhombus. This is really pretty cool when you think about it. If you are trying to build something, put some wood pieces together, and you want it to be absolutely perfectly square, the corners, all you need is a string. You can do it with just a string or just a tape measure, but you got to just measure the diagonals. If the diagonals are exactly the same, then you know your figure, your parallelogram is a square, meaning the sides are perpendicular. It could be a rectangular, that's fine. But what I mean is that the corners are exactly 90 degrees. Just with a tape measure is all you would need to show that. Now, how about a square? We have not talked about a square at all. Well, what you need to remember is that a square is a type of rectangle. So a square, the diagonals of a square are congruent. When I do the diagonals of a square, they're going to be exactly equal to each other. A square is also a rhombus because the sides are the same. So the diagonals of a square will be perpendicular to each other. And they will also bisect the opposite angles, cutting those 90-degree angles into 45s. So a square would have all of these characteristics. If you know it's a parallelogram and we're not dealing with diagonals, you can tell from the sides. If I have two consecutive sides of a parallelogram that are congruent, then I know it's a rhombus. If two of them are the same, all four will be the same, and it will be a rhombus. You just have to make sure that you know it's a parallelogram and not a kite. Same thing here with bisecting the angles. You start with the fact that it's a parallelogram. If the angles are bisected, you know it is a rhombus, because kites' angles also get bisected, and kites also have consecutive congruent sides, so don't get fooled by that. We're going to do kites later on. This is just special types of parallelograms. Okay, this last theorem is about parallel lines. If I have two lines that are parallel and I just have 2 points on them, like this point A and this point C, those 2 points will always be equal distance from the other parallel line. AB, this distance, A to B, will be exactly equal to of C to D. In other words, if my two lines are parallel, any point on them, they're always going to be equal distance apart. They're not going to get closer together and farther apart, otherwise they wouldn't be parallel. That's this last. And that has to do with rectangles. Okay, here's a rectangle, and I have labeled the diagram. Hopefully you can see it. I would like to find all of these. Can you do it? In fact, please pause the video, try to work through them and figure them out. See if you can see what they are. Restart the video, and I'm going to walk through and check yourself, see if you got it right. Okay, the first one is angle WTU. We found STW here is 60, so what is WTU? Remember, this is a rectangle. That means it has 90-degree corners. If this angle is 60 degrees, then that other angle is 30, because 60 plus 30 is 90. So this would have to be 30 degrees. Hopefully you got that in order for that corner to be a 90-degree corner. Then it asks for WU, TV, and TW. Because SW is marked 4, then WU is also has to be 4. Remember, a rectangle is a special type of parallelogram, and in parallelograms, the diagonals bisect each other. So if this half is 4, the other half, WU, is also 4. Also, since it's a rectangle, the diagonals are congruent. Since SU would have to be 8, then TV would also have to be 8. And again, diagonals bisect each other, so half of 8 TW would have to be 4. That's the way diagonals work in rectangles. Okay, the next one, angle TSW and angle TWS. TSW is here and TWS is here, so we're looking for the other two angles in that triangle up there at the top of this rectangle. This is a rectangle, so these diagonals treat the angles the same. So angle TSW would have to be 60 degrees. And if that's 60 and that's 60, then in order for them to add up to 180, the other one must also be 60 degrees. So those are both 60 degrees. Next, we're looking for angle TWU. TWU would be here. We've already established this is 60 and this is a linear pair, so that angle would have to be 120 in order for them to add up to 180. So that's TWU. WUT would be this angle here. This is 30, we figured out earlier. This is 120, so that also has to be 30, so that those three angles would add up to be 180. Okay, the last two you need to put your thinking cap on. ST and TU. ST is not too terribly bad. It's the length of this side of this rectangle. We've already established that triangle at top, STW, is equal angular. That means, since all the angles are all 60, all the sides have to be the same. And since SW is 4, that means ST would have to be 4 as well. So ST is not bad. But how do we find the length of the other side of TU? Now, the best way to do that would be to isolate this half of the rectangle like this. This is 4, this is 90 degrees. We've already established that this is 60, which means this is 30, and we're trying to find this side right here. This is a 30, 60, 90 triangle. In this 30, 60, 90, we already have the short leg. We need the long leg. And if you remember, in a 30, 60, 90 triangle, and if you don't, it should be in your notebook, that the long leg is the short leg times the square root of 3. So TU is 4 square root of 3. That one was hard. Give yourself extra bonus points if you figured out that. So that's how to take all the different parts of a rectangle and figure them out because you know the characteristics of a rectangle. Okay, let's do a similar one with a rhombus. I've drawn a rhombus. I've labeled it. Hopefully you can see all of this one. These are all the parts of it I want to find. Pause the video. Some of it's going to be really easy. Some of it's going to be challenging. See if you can see the relationships and figure it out. Then come back and I'll walk through it with you. Okay, the first one is the measure of angle PQM. This is a rhombus. Therefore, the diagonals are perpendicular. So hopefully you got that that was 90 degrees. All right, now I want to find QON, this angle, and QNO, which is this angle, labeled 3x and 7x. How do I find those? The secret is remembering that this is a right triangle. So therefore, 3x and 7x, when I add them together, would have to equal 90 degrees. That's the secret. So 3x plus 7x equals 90 degrees, so that all three angles would add up to 180. So 10x is 90, so x equals 9. If x equals 9, then QON is 3 times 9, or 27 degrees, and QNO is 7 times 9, or 63 degrees. And we have found those two angles. Okay, next we've been asked to find QP and MQ. Now, because this is a parallelogram, the diagonals bisect each other. And since NQ is 2, that means PQ or QP also has to be 2. Now, how do we find MQ? Well, PQ is y minus 1. Y minus 1 is equal to 2. That means y equals 3. And since MQ is y plus 1 and y is 3, then MQ would have to be 4. There's clues everywhere for you to solve this puzzle. It's like solving a big puzzle. It's fun. All right, and now we're asked to find MP. So we know that this is 2, and we know that this is 4, and this is a right triangle. So what you can use is the Pythagorean theorem, if you need to find MP. So 2 squared plus 4 squared equals that diagonal, or that hypotenuse squared. That's 4 plus 16, so that is 20, or the square root of 20. And since 20 is 4 times 5, we want to be really precise and call it 2 square root of 5. MO, which is the next one, is much easier because that is just this diagonal here, and we know this half of the diagonal we already figured out was 4. That means the entire diagonal must be 8, and we did it. How did you do? This is the kind of problems that we can solve if you understand the characteristics and the qualities of rectangles and rhombuses. So we'll stop there for now. Make sure that your notebook has these detailed things in it so that if we leave it for a while, you can come back and refer to it and you can find it. And have fun solving these puzzles, these rectangle puzzles and these rhombus puzzles. And the next building project you do, make sure those corners are square. And I'll see you guys in the next section.